So in this video, we're going to learn the concept of area of a trapezium. So first of all, what is this new shape trapezium? So this over here is a trapezium. That is, it is basically a four-sided figure in which one pair of opposite sides are parallel. I repeat, it is a four-sided figure in which one pair of opposite sides are parallel. Like over here, AB and CD, both the blue lines are opposite sides, and AD and BC, both the red lines are opposite sides. But over here, AB is parallel to CD, right? So it is a four-sided figure in which one pair of opposite sides are parallel. That is what a trapezium is. How is it different from a parallelogram? See, in parallelogram, both the pair of opposite sides are parallel. But in the case of a trapezium, only one pair of opposite sides are parallel. Now, what is the base and what is the height? See, each of these parallel sides is the base. I repeat, each of the parallel side is the base, and the distance between these two parallel lines is the height. So what is the base? Each of the parallel sides is the base, and the distance between the two parallel sides is known as the height. So these are the basic terms related to a trapezium. So what is a trapezium? A four-sided figure in which one pair of opposite sides are parallel. Each of the parallel side is called the base, and the distance between the two parallel sides is the height. Now we know distance between two parallel lines is always the same. So this height AE is equal to this height BF. I repeat, distance between two parallel lines is always the same. So AE is equal to BF, right? So this is what a trapezium is. Now what we're interested in finding is the area of a trapezium. So how do we find area of a trapezium? I have base, I have height. So when I say the words area, base and height, what comes to my mind? Area of a triangle is half base into height. I repeat, area of a triangle is half base into height. So we'll use triangles to find the area of a trapezium. So how do I use triangle? Let's try to form a triangle. So whenever you have a four-sided figure and you need a triangle, what do? Make a diagonal. So let's say we join either B and D or A and C, your choice. So let's say we join BD. So let me join BD. It's not a very straight line. So I've joined BD. So we have two triangles, triangle DAB, this is one triangle, and triangle DBC, this is another triangle. So whenever you have a four-sided figure and you need a triangle, simply make a diagonal. So we have two triangles, DAB and triangle BDC, right? So let's find the area of each of these triangles. So let me rub off this. So you know this is the height. So we'll begin with area of triangle. Let's say we take this triangle, triangle DBC. So what is area of a triangle? It is half base into height. So area of a triangle is half into base into height. So let's plug in the values. Half into, what is the base of this triangle? It is CD, into what is height of this triangle? The perpendicular from B onto the base, BF. So half CD into BF. I repeat, what is area of a triangle? Half base into height. So for this triangle, I repeat, what is area of a triangle? Half base into height. So for this triangle DBC, base is CD. What is the height? From B onto the base, the perpendicular. Here BF is the perpendicular, so BF is the height. So half CD into BF. This is area of triangle DBC. Similarly, let's get the area of triangle DAB. So area of triangle DAB. So again, we'll use the same formula, that is half base into height. So let me write in blue. Half into, now for this triangle, what is the base? AB is the base, multiplied by height. What is the height? See, in this case, EA is the height. I repeat, for this triangle, what is the height? EA is the height. So EA or AE is the height. So half base into height. I repeat, what is height of this triangle? From the base to D, what is the distance? It is AE, right? So half base into height. So we have area of both the triangle. Now what is area of this trapezium? Area of this triangle plus area of this triangle. So let me write it down. So area of the trapezium ABCD is area of this triangle plus area of this triangle. Let's plug in the values. What is area of triangle DBC? Half into CD into BF plus what is area of triangle DAB? It is half into AB into AE. Right? Now we know that AE is equal to BF. I repeat, AE is equal to BF. Why? Because distance between two parallel lines is always the same. So A is equal to BF. So let's say the height is H. So A is also H and BF is also H. I repeat, AE is equal to BF, that is equal to H. Why? Because distance between two parallel lines is always the same. So we can replace BF over here by H and we can replace AE over here by H, right? So distance between two parallel lines is always the same. So AE is equal to BF is equal to H. So I replaced it by H. Let me write it in red so you don't forget. So now in these two expressions, what is common? Half over here, half over here, half is common. H over here, H over here, H is common. So this is equal to half into H. What remains in this expression? Remove half and H, CD plus remove half and H. What remains over here? AB. So this over here is the formula for area of a trapezium. So half into H into CD plus AB. So let me write it in a more nicer way, right? Which is easier to remember. So what is area of a trapezium? It is half multiplied by what is AB and CD? AB and CD are the bases. So sum of the bases, that is sum of parallel sides, multiplied by height. So this over here is the formula for area of a trapezium. That is half into CD plus AB, sum of the parallel side, multiplied by height, that is distance between the parallel sides. So this is the area of a trapezium. I repeat, what is area of a trapezium? Half into sum of parallel sides into the distance between the parallel sides. So whenever we have to find the area of a trapezium, what do we need? We need the length of the two bases and we need the distance between the two bases. So what is area of a trapezium? Half sum of parallel sides multiplied by the distance between the parallel sides. So this is how we find the area of a trapezium. So let me do a recap. What is a trapezium? It is a four-sided figure in which one pair of opposite sides are parallel. Each of these parallel sides is the base and the distance between the two bases is known as the height of the trapezium, right? So what is area of a trapezium? It is half sum of parallel sides into the distance between them, right? So half sum of parallel sides into the height of the trapezium or distance between the parallel sides. How do we derive the area of a trapezium? See, we divide the trapezium into two triangles. How do I get that? Join BD or you can join AC. So when I join BD, I got two triangles, triangle DBC and triangle DAC. What is area of a triangle? Half base into height. So what is area of triangle DBC? Half into base, that is CD, into height, BF. Area of triangle DAB, half into base, that is AB, into height, that is AE. Now AE and BF, what are they? They are distance between two parallel lines. Distance between two parallel lines is always the same. So AE is equal to BF, that is H. So I replaced BF and AE by H. So we have area of trapezium is sum of these two areas of the triangle. Plug in the values, take common. So half into H into CD plus AB. So half multiplied by sum of the parallel sides into height, distance between the parallel sides. So what is area of a trapezium? It is half into the sum of parallel sides multiplied by the distance between the parallel sides. So this is the concept of a trapezium, base and height, and this is how we find the area of a trapezium.